Good afternoon, good morning, good evening, and welcome back to our chemistry lesson. It's been a long weekend. We were supposed to meet yesterday, but because of the weekends of here and there, we did not manage to have our lesson yesterday. But today, I'm happy that we have managed. We are back. We are here, like we never left to anywhere. So, thank you for you have waited for me, and I would like to talk to all of you. I would like to welcome you to our chemistry lesson, and the topic is structure and bonding. Structure and bonding, and I'm going only to deal with one structure and bonding, and that is ionic bonding and giant ionic structures. That's what I'm only going to discuss for today. So if you can hear me, let me get a hello on the chat section, or just say hi. At least I know we are together, we are following each other. And then we start our lesson today. You can tell me how was your weekend. Tell me if I'm audible enough as you are proceeding. But from now going forward, we shall always be having our lessons. There will be no any other interruption. I don't think there will be anything that will be interrupting us. Nimemalizana na sherehe za December, sasa ni kusoma mpaka tufungue shule. I know some of you are here to start their sherehe. Mimi nimemalizana nazo, sasa ni kuanza masomo. Are you together? Can you hear me? If you're on, let me get if you can hear me so that we can proceed very fast. We can proceed very fast. Timothy Munga, let me hear if you can hear me. Let me know if you can hear me. And anybody else in class. Yes, you have waited kidogo, at some point we were to start some 20 minutes ago, but because of 1212, mnajua kuna mashughuli mingi, tumedelay for some few minutes. So where are you watching me from? Can you hear me? Am I audible enough? Let me know if you can hear me very well. Those who are in class. Yes. Fate, CS, Crispin Rakula, thank you for confirming that you can hear me. Yeah, now we can proceed. The topic nishaandika nimesema structure and bonding. So this topic is made up of two words. It's made up of the word bond, ama bonding, then we have structure. Yes. Those two words are the ones making up the topic that we are supposed to discuss today. So I would start by discussing what is bonding, what is structure. Then now we start by looking types of bonding that exist. Now, this bonding is used especially on the time when a compound is formed. We all know a compound. Si compound ya kwenu ati compound yetu ni kubwa, hapana. Naongea kuhusu elements. For example, look at this. CO2. This is a compound. What is the name of this compound? Carbon 4 oxide. This compound is made up of carbon and 2 atoms of oxygen. They form a bond. The force of attraction between oxygen and carbon. The force of attraction between oxygen and carbon is what we are calling it bonding. The mutual force of attraction between carbon and oxygen is what we are calling it the bond. Now, the structure, the pattern formed by carbon and oxygen forming a compound is called structure. So can you write this? Can you write this? Let me define for you. Can you write this? Na nikisema uandike unaandika haraka. A chemical bond, ama bonding. A chemical bond or bonding, can you say it is the mutual force of attraction that holds the particles of atoms of the same or different elements together. You see? These ones are of different elements. Lakini kuna ingine kama hydrogen. Two atoms of the same element are being held together by what we call a chemical bond. So that is it. Number two, let me give it the definition of a chemical bond to a structure. I'm placing it on your chat section, and the technician will place it on your screen. So that is the definition of chemical bond. It is the mutual force of attraction that holds the particles of atoms of the same or different elements together. That is how to define chemical bond. Sawa. Structure, when we talk about structure, it is a regular pattern. That's what you need to know. Structure is a regular pattern. Yes, after chemical bond, I've also given you the definition of structure, which is a regular pattern in which chemical bonds hold the particles of a substance or a compound together. It is there with you. Yes, I think now you can have the definition of structure and bonding. Pale kwa bonding, you can say bonding, you can say bond, or you can say chemical bond. It means the same thing. Nilikuwa nakumbusha mwingine nikaambia 3 weeks to school, akaniambia teacher hiyo usiseme. Akaniambia hiyo usitukumbushe, tunajua lakini usitukumbushe sana. Now, before we look at ionic bond, let me say this. Elements combine together to form compounds. Elements combine together to form compounds by losing or gaining electrons. Look at this. Sodium and chlorine. They form a compound known as sodium chloride. Sodium will lose electron. Chlorine will gain electrons. When they gain electrons or when they lose electrons, they become stable. They become stable like the noble gases. Now this compound formed, one of it should be positively charged because it may lose electrons. The other one should be negatively charged because it may gain electrons. Are you together? Yes, so that is how it should be. You know, lazima ujue, one is gaining, the other one is losing. I was telling you this last week. Do you know oxygen can form compound with chlorine? In the realities, we know all of them are supposed to gain electrons, but in the event this has to form a compound, oxygen has to lose electrons to chlorine. But in the normal location, one is losing, the other one is gaining. Now, for example, look at this. See, it forms a positive ion, this one forms a negative ion. There is a law of charges which says like charges repel and like charges attract. So they will attract each other. When they attract each other, it brings about the bonding. Because one is negative, and that one is positive. And in the process, it gives a certain pattern. And that pattern, we call it structure. That's why we are talking about structure and bonding. So there are various types of bonds. Bonding that exist. And based on those various bonds, it gives various structures. A structure comes from a bond. A structure comes from a bond. A structure comes from a bond. Can you hear me now? Yeah. So we are going to look at what we call ionic bond. For today, we are only discussing what we call ionic bond. Ionic bond. Then, after discussing ionic bond, we will look at the structure associated to ionic bonding. Tuko pamoja? Now tuanze. What's ionic bond? I'm taking you slowly because for the first time. So staki niende mbio sana. Ionic bond. First of all, the other name of ionic bond, can you say it is called electrovalent bond? Electrovalent bonding. I'm a bond. This is the other name of ionic bond. So in the event you come across electrovalent bond, don't say sikia hapana, it is just ionic bond. Sawa sawa. So but the most commonly used name is ionic bond. And this ionic bond is electrostatic force of attraction between two different charges, like a positive and a negative. Ionic bond, again, look here, it is formed by a metal and non-metal. Ukiona tu metal and non-metal forming a compound, that compound has a bond called ionic bond. Except, I must say this, except one, aluminum chloride. Aluminum chloride, ngoja, aluminum iko na valence ya aluminum chloride iko na hapa ikwe 3. Yeah, okay, sawa sawa. Aluminum chloride. Bond. This one now is one of the special cases because it is a metal and a non-metal. Badala itupe ionic bond inatuambia nini? Covalent. It's a special case. But generally, a metal and a non-metal forms a compound with ionic bonding. During ionic bond, unajua nilikuwa nimewaandikia ya sodium na chlorine. During ionic bond, electrons move from sodium to chlorine. Chlorine receives electrons from sodium. So we say there is a complete transfer of valence electrons. There is a complete transfer of valence electrons. I hope bado mnakumbuka maana ya valence electrons. So that one is will give us what we call the ionic bonding. As far as there's a complete transfer of valence electrons, we will call it ionic bond or electrovalent bond. Are you together? Yes. Nice, nice. Now, let's define ionic bond. Let me give you the definition of the ionic bond. Check on my chat section. Okay, ionic bond. It's not complete because sawa sasa kidogo tu, I'm typing for you. That is how it is. The definition of ionic bond is formed when there is a complete transfer of valence electrons from one atom to another, resulting in two ions with opposite charges which mutually attract one another. Sit hapo tuko pamoja? Yes, so that is the definition of ionic bonding. Let's proceed and say this. I will give you only 3 case examples, then you will be able to get the 4th one and the 5th one. Sasa, before I give you examples, compounds having ionic bond are called ionic compounds. I hope umenishika vizuri. Compounds having ionic bond are called ionic compounds. After nimewapea examples 2 ama 3 ya how ionic bond are formed, then we will see the properties of ionic compounds. An example of ionic compounds is sodium chloride, magnesium chloride, a metal and non-metal. Sodium oxide, vitu kama hizo. Now look at this. I talked about valence electrons. I hope we all know. Wacha niwape example moja. ndio tuendelee vizuri. Okay, I will give you 3 examples ndio mtu asiseme ati si kumbea. So nataka to see how sodium chloride is formed. Sodium chloride compound is formed. So first of all, we have sodium here. Hii nimechora vizuri kweli, but siko sawa. So it has we have 11p 12n. So we have 288 ngapi? 288. Kumbuka ni 281. So hapa ndaweka ingine ikuwe na 1 pale. That is a sodium atom. Now it's supposed to react. This pen of mine is emitting some ink. Supposed to react with chlorine. Chlorine, kumbuka. Iko na 2. Okay, I will use now dots ndio differentiate. So hapa tutoka na moja, hapa mbili. Kumbuka electrons are supposed to be together in pairs. Huwezi pata ikiwa peke yake unless if it has to be one kama hii. So this one is chlorine 287. Then what is it giving us? Now sodium will lose the valence electron 1. Chlorine will gain 1 on the other side. My body is small, but haina shida. So it's going to give us so we have 11p 12n. So it's going to be 28. Why? Alafu lazima nifanye hivi na nifanye hivi na niweka pale plus. Hapa ilikuwa 281. Hapa itakuwa 28 hivyo tu. Why? Because it's now a sodium ion. Hii ilikuwa sodium atom. Then plus. Don't even say plus. Now another one like this ningechorea huko lakini hakuna space, ndaichorea hapa chini for chlorine. But remember chlorine iko na 17p 18n. So hapa chini ndachora ya chlorine 17p 18n. Hii kuweka dots kidogo inachoshanga, lakini I will have to take time niweke hivyo. Then sasa ilikuwa 287. So hapa tuko na 2, hapa tuko na 2, hapa tuko na 2, hapa tuko na 2, hapa tuko na 2. Kumbuka kuna moja ilikuwa pale juu hapa. So hiyo moja kuna ingine yenye tumegain. So nitaweka ikiwa negative. The one that imegain iko negative. The one that ili lose iko nini? Positive. Na hapa uandike 288, but it is chlorine ion. My body is small. Maybe next time you will buy me a bigger one and nisikue na ipeleka chini hivyo. Good. That's the first example. So this one is losing, this is gaining. After losing it becomes positive. After gaining it becomes negative. Don't forget to put the negative sign there. Kama ime lose 2 ningeandika 2 minus. Kama inge lose 2 ningeandika 2 plus. Ama inge gain 2 ningeandika 2 plus. So don't confuse about that. Ndaka nifanye kitu inaitwa magnesium au ni potassium fluoride. Potassium and fluorine. Ndaka tufanye potassium and fluorine. Yes, are you ready? Allow me to clean the board. And we want all of us to improve in our grades in chemistry. We have to improve in our grades in chemistry. Everybody. Next year I'll be working to make sure everybody improves on his or her gradings in chemistry. And you have to improve actually. Whatever I'm teaching here, these are just what I would like you to master the content on. Now, potassium and fluorine. Wacha niulize watu hapo. Give me the atomic number of potassium and atomic number of fluorine. Very fast. Ndio tuendelee. Potassium iko na atomic number ngapi? Fluorine iko na ngapi? I'm waiting for you ndio tuendelee. Fast kidogo. Fluorine and chlorine. I'm waiting for the atomic number of fluorine and the atomic number of potassium. Hiyo na wangojea haraka sana. Tuharakishe kidogo. Atomic number of fluorine and chlorine. Nikipanguza kalamu inanisumbua. Timo, iwezi kwa ujui. Aya, sawa. No one knows. Let me check the other channels first because wale wa ambassador speaks hawajui. Wacha niende ya shifting alafu niende ya Mickey Slate Media. Here we have 3 channels. So watu wa ambassador, my followers, hawajui kikenye tunaongelelea. Wacha nione kama sasa kidogo tu nione ya wale wengine juu nyinyi umeshindwa. Shifting rates amjui atomic number ya potassium and atomic number of fluorine. Ambassador speaks the same. Mixed Media nobody knows. Sasa hapa, because you don't know, let me give you the answer. Potassium has atomic number of 19. Fluorine has atomic number of 9. Right together? Sasa nimeona nyinyi mnataka kushindwa tu vitu ndogo tu pure yenye haifai mshindwe. Sawa. Aya. So let's proceed. Somebody is saying that Faith inbox me. Wewe Prosper TV. Bwana ukunitaka kuwa inboxed. Aya. Now, let's look at the compound formed by potassium and fluorine. Tumeangalia sodium and chlorine. Do at least you see how it should be. So the electronic configuration of potassium is 2881. For fluorine, because it is atomic number 9, it is 27. So tuanze na hivi potassium. I will try to nichore ndogo. I hope itaonekana. So hapa ni 19. Because hapa ndani lazima uandike the number of protons and also the number of neutrons. 20n. Na uandike hapa ni 2881. 28. Then niongeze ingine. Najua nimechora vitu mbaya lakini at least iko na shape. Kuliko vidole zako za miguu, si ndio? 1. So you need 281. 2881. And this is potassium. To react with fluorine. Fluorine, wacha hii ni nucleus. So So apart from nucleus yenye ndaandika hapa 9p, then you write also 10n, 10 neutrons hivi, so itakuwa tu hivi 27. Hii ni mbili 27, and this is fluorine which is 27. Now what is going to happen here? The potassium is going to lose this one. It's going to lose this one. Fluorine is going to gain the one. So what's going to happen here? You will have kumbuka hapa ndani itabaki 19p 20n. The nuclide does not change. Why? We are not losing protons or neutrons. So it will remain 19p 20n. So then we have 2, then 8. Na kama umetumia ingine x ama cross, hiyo ingine utumie dot. So 2, 8, 8 ime lose 1. Good. Then niweke hivi, ili lose 1, so ni positive. Then for fluorine, lakini inafaa niweke hivi, nichore ya fluorine hapa ndani na niweke nini? Negative. So whatever I'm supposed to draw it inside here, wacha nichore hapa chini. Then n, then we have 2. Then we have 2 hapa, 2 hapa. Make sure umeshade vizuri, wachana usikone kama mimi. Then hapa tulikuwa na kadot moja lakini tumekei nyingine from outside. Then weka hivi na weke dot. Itakuwa 2, 8 imekei in 1 na ni negative. That is for potassium fluoride. I hope we are together. Sawa. So anybody with a question? If there is no question up to that point, ndaka tumalizie hivi. In fact, those two examples are enough. You can check on others in our notes. For those who have these notes, nilikuwa nimeanza nikasema ensure you have notes on ionic bonding, so you can go and check more and more. Now, what is there here is let's look at the properties. Properties of ionic compounds. Properties of ionic compounds. One, most ionic compounds are soluble. That's the property number one. They are soluble. Why? Because they are made up of oppositely charged ions, which are attracted by the polar water molecule. So what am I saying? They are soluble. Number two, what about their melting points? They have very high melting points. Why? Ionic bond are a very strong bond that requires a lot of energy to be broken. That is number two. Property number three, they conduct electricity in molten or aqueous state, but they do not conduct electricity in the solid state. Who can explain that? That's a very good question that someone can explain. Ionic compounds like sodium chloride, potassium fluoride, magnesium oxide, sodium bromide do not conduct electricity in solid state. They do so when in molten or when in aqueous state. Are we together? Yes, so what you need to know, and by the way, you will meet with these questions. Somebody will ask you about solubility. Another person will ask you about melting and boiling point. Another person will ask you about conduction of electricity. You must explain the way we have said it. So, for example, I can ask you, comment on the solubility of ionic substances in water. You must explain that they are very soluble because they have oppositely charged ions which are attracted by the polar water molecules. Number two, explain why the melting and boiling points of ionic compounds are extremely high or they're very high. You say bonds that requires a lot of energy to be broken. Explain why ionic compounds conduct electricity in aqueous or molten state but not in a solid state. What do we say? They do not conduct in solid state because in solid state the ions are fixed. The ions are fixed. Number 2, in aqueous state or molten state, the ions are free, so they can conduct the current. Hapo tuko pamoja? Now, what is the name of the structure formed by compounds having ionic bond? The name is giant ionic structure. You can check the diagram in your books. Sawa sawa. So someone is saying we do for sodium oxide. Okay, you want us to do for sodium oxide? We will do it. We will do for sodium oxide. In fact, tutamalizia na hiyo basi. Beverly, sodium oxide. Let me clean the board to find sodium oxide. Then we end there. Yes, so sodium oxide. So we must have sodium, which is 11B12N 2 8 to 8 to 8. Ngoja kumbe ni 281. Yes, so hiyo one tuweka hapa. This is sodium, then plus oxygen, which is going to be in oxygen, so it's going to be, what is the atomic number of oxygen? Oxygen nakwanga 2:6, so it is 8P and 8N. Sawa. So we have, I will use dot now. Yes, so that is so this is oxygen. But kumbuka sodium oxide inaandikwa hivi. Atoms of sodium and one. So let's proceed in David. So we are going to have, sodium is losing one, so we are going to have a sodium ion, which is 11P 12N. So it's going to be 2 8. Then we have 8 here. 8 then nikiweka hivi itakuwa sisi lose, so it's going to be positive. But kumbuka we need 2 atoms ya sodium, so ndaandika hapa 2. Hii ingine ya huku ndaenda hivi, but because haiwezi totoshea, wacha nichore hapa for oxygen. So it's going to be 8P. Kumbuka hii ingine haiwezi ka change 8P, then sorry, ini dots 2 7. So lakini sasa hii ingine ni 2, itakuwa imekaa 2, lakini kumbuka nitaweka hapo negative, lakini nitaweka hapa no, I just put 2 negative because ni ilikaa 2, Yeah, how it should be. But if you have to write equation ya formation of sodium oxide, lazima tuweke tu hapa how it should be for sodium oxide. Let's kama kuna swali lingine, we will stop there for today. Niangalie channel lingine. Someone is asking kama tunafanya Kofaland leo. Kofaland ni kesho. Hatuwezi fanya Kofaland leo. We'll be doing for Kofaland tomorrow. So in the next 1 minute, we will be stopping. So I would like you to, if you have any question, do it right now in the next 1 minute before we end. Yes. Remember, you have assignments ya kufanya. Every school gave you assignment. We are here to remind you on the same. Do your assignments and make sure umemaliza, ndio usiende kupigana na walimu. Otherwise, we are out in the next few seconds. So thank you for attending our lessons. Tomorrow we meet at 3 p.m. for covalent bonding and any other thing that we are going to discuss. Otherwise, have a nice evening. Vicky? 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 Tumemaliza? Tumemaliza?